Today we'll take a look at creating enemies for our game and some other things along the way. So just like with our player, we'll start by creating an enemy class which inherits from game character, and we'll override create and update function. We'll also make some helper functions which will get the state of our enemy, make the enemy receive damage, and we'll just get enemy's health. We'll also make an enum. Normally you'll make some more complex system like an finite state machine or whatever for enemies, but since our behavior will be very basic, a simple enum will suffice. As you see, we have only 5 states here. By default, enemies will go towards the castle, and if they reach the castle, they will attack it. Otherwise, they'll go after the player and try to attack it, and as a fallback, they'll have an idle state in which they'll do nothing. He will also have some member variables like hit points, damage, attack cooldowns, timer after which the body despawns, the state of the enemy, and some values for at which radius the enemy should follow the player and attack the player or the castle. Now, before looking at the implementation, let's also take a look at the object class of the enemy. It looks similar to what we have for the player, and here we have, for example, the radius for attack and follow. So these 3 members will be defined in data instead of code. We could define all of this here, and the benefit of this is that if we want to change some of these values, we wouldn't have to recompile the whole code, since it would be stored in data and not in code. But I won't really be changing any of these, so it's fine. I'm just too lazy to make it all here. And you can also see that I set some of the animations as object class parameters. So you can see the idle animation and the walk animation. It is another way of defining these. You can see they have the type of element ID, and to get them here you just drag from the resources into this window here, and they get set. Once again, the benefit of this is that we can change these values without recompiling the program, so it saves us some time. Now let's look at the implementation. First, we create the enemy. We call supercreate just like before. This is the same movement fix that like we had for the player. And we also have these 2 lines, move, walking, and speed. You can see they are defined in game character. And why we need to set move walking to true is because the speed, when we set it like this, only affects the walking speed of the character, and by default the character is running and not walking. So if we change this value without setting this to true, the speed won't change. And I want the enemies to be a bit slower than the player, so that player could run away from the enemies if they need to. Here we get the parameters from our object class like we did before. We find the parameter by name and we set it to the value. You can see that we set the animations the same way as before, but instead of doing it like this manually, so we hard code these IDs here, instead we get them as ID and set this animation. So here's parameter as ID. And here nothing new as well. Now let's look at the update function. Here we update the base class and we check if the HP is 0 or less than 0. If it is, then we start counting down the death timer. So if we have the death timer at 3, so the body of the enemy will lie on the ground for 3 seconds, and once these 3 seconds pass, the body disappears. You can also see that I enable ragdoll. Ragdoll is once again handled by the character. You can see there are some functions for this, and ragdoll enable will animate the body based on ragdoll and not on animations of the skeleton. Note that to make ragdoll work, we need to go to our object, to the ragdoll tab here, and set some of the bones to be ragdoll. So ragdoll will be based on them. You can see that the skeleton is a bit messy. I guess it's because this model was animated with something like Mixamo, so it was not manually animated, which is why it's all over the place, but it still sort of works. And you can see there is a toggle bone here, which you can use to toggle bones to include in the ragdoll or not. So I've included these bones in the ragdoll, and I've not touched other ones. After this we have action break. What it is we'll look a bit later. And we'll also have an attack cooldown. So this will be a cooldown used for attacks. It is, I believe, set to 1. So the enemy will attack every second. And we continually count this down. You'll see how it is used a bit later. Then we have a simple switch based on the state. So we'll go through these states and do what we need accordingly. So if we have the state of walking towards the castle, we need to make several checks first. So if the player exists, so there is at least one player in the container, and the distance, dist is a function, one of many math functions which the engine has, which checks, well, the distance between, in this case, two vectors. We could use distance squared, but I don't really care. If the distance between the player and the position of the enemy is less than the radius at which the enemy starts following the player, then we want to start following the player. And we return out of this function so that we don't do anything else. We just switch to following the player. If this check fails, we go further. So if the castle exists, and the distance from it is less than distance at which the enemy attacks the castle, then we start attacking the castle. And if the distance is not yet in attack range, we set an action to move to the castle. So what this action move to is one of 3 functions that are defined in the character that control the actions. An action is some, well, action that the character performs automatically. So if we set action move to, then for every frame after this call, the character will move towards this position and only stop this action after it reaches the position. Well, as long as it can find the path, that is. Yeah, so it checks the path every frame and walks towards the target. And this is why we needed action break. So when we had action break here, since we check the state and update the state each frame, we want to set this action each frame, because one frame the enemy can be walking towards the castle, then the next frame they encounter the player and start following the player. So if we don't call action break, which breaks or stops the action, then the enemy will just start walking towards the castle and never stop until they get to the castle. And it's not the behavior we want. So we break the action, then check the conditions, and if the conditions pass, then we again make the enemy move towards the castle for this one frame. Well, and if for whatever reason the castle doesn't exist, then we go to the idle state, and we can look right now that idle state just does nothing. Now we can look at the state of following the player. So if there is no player for whatever reason, we go back to going to the castle. If the player is in attack range and the attack cooldown is less than 0, then we go into the attack player state. If the player has moved too far away from the enemy, so in this case the following radius from the enemy, then the enemy goes back towards the castle. So they lose interest in the player and they go towards the castle. And if the player is further away from the enemy than the attack radius, then we once again move to, but in this case not towards the castle but towards the player. In the attack states, we just attack whatever we need. So if the castle doesn't exist in castle attack state, then we go to the idle state, and if the cooldown is less or equal to 0, then the castle receives damage. And we set the attack cooldown so that it starts ticking from that 1 second again. And we can see that once the enemy starts attacking the castle, they don't stop, so I don't want the enemy get distracted from attacking the castle and start attacking the player, since the castle is their main objective. In case of the player, we do mostly the same, but in the end we go to the state of following the player. We do this to check if the player has moved too far, and if they have, then we go back to attacking the castle. So this is the difference between these two states, is that once you start attacking the castle, you don't stop, and once you start attacking the player, you still can stop and go back towards the castle. And here are just our helpers. Data string, we just get string to show on screen, receiving damage and getting health, nothing to explain here. Once again, in the main file, we create a container for the enemy, and we set the object type to object enemy so that it gets updated accordingly. You can see that we also, for each enemy, we draw its state and its health, so we iterate over the container of the enemies and draw text on the screen. Pose to screen is a useful function that takes position in the world and translates it into the position on the screen. So we draw the state of the enemy at the enemy's position, and we draw the health of the enemy at the enemy's position plus a bit up so that the text doesn't overlap. Since the enemy now also attacks players and castles, I'll also draw player and castle health. They will be shown on the screen in the lower left. And since we now have enemies, I also wanted to add a way to attack these enemies. So last time we created the Projectiles class, which handled player projectiles. But we didn't have any visuals for them or any logic, they just flew in a straight line and disappeared on contact. So to change this, let's first give them some visuals. To do this, we go to our object class and we set draw as, not as mesh as we had it before, but as particles. When we add this, we see that we get a ton of parameters on top of our free parameters like direction, radius, and speed that we had before. We'll also get a lot of parameters related to particles. And if we now go to our projectile object, you can see that I made some basic graphics from particles. So we can see in the params, I set the image to this, and I changed some radius, shape parameters to make it look like this. You can play around with these and see what you can get. I just made the very basic ball of fire. And I also made another object, which is called impact, and it will be spawned each time particles encounter an obstacle and get destroyed. So they'll have some explosion on contact. And now let's look at how the code for these particles changed. So first let's look at our projectile class. I changed it from being a kinematic object to object particles. Object particles is just an object class that is made for handling objects that just consist of particles. But since it's designed only for particles, it didn't have any physical actor of its own, so I had to add an actor that will update manually, just to check for collision. The create function didn't change, but in the update function we do something a bit different. First, we need to create another class which inherits from physics cuts callback. So this is a callback that can be called each time physical objects cut one another. So if we look at it, it just consists of a single hit method, and it receives an actor info object. Actor info consists information about a physical body, so about an actor. Gets information about collision if the actor is dynamic, about its group, and some other information like a pointer to its object. What this group is you can assign different groups to physical objects, and it is sort of like layers, physical layers in other engines, so you can, for example, disable collisions between certain groups of actors and check only for collisions between certain groups. We won't be doing this here, but you can do this. And so what we do, in this class we have a container for enemies that we will hit. It is a container and not a single pointer, since one projectile could hit several enemies on a single frame, so it's better to make this a container so that we hit all the enemies and not just one of them. And in the virtual hit function, we check if we can cast the object we hit to enemy, and if we can, we add this object to our container. And then in the main update function, first we manually update the actor position, so we set its position to whatever position our particles have. Then we create an instance of this approach collision, and we run a physics test to see if the box of this actor intersects with whatever physical object. And after this check, this hit will be called, and if whatever this actor cut was an enemy, then this enemy will be added to this enemy container. Now we can iterate over the container, and for each enemy they will receive some damage, in this case just 5 damage. So once again, each frame we check for collision, and if a collision occurred, we check if the object we collided with is an enemy, and if it is an enemy, then this enemy receives damage. And then we check just once again if this actor cuts anything, and if it does, then we spawn an impact. This is this impact object in the world like we did before. And in the end we just update the position, so if nothing occurred and the projectile didn't disappear, then we just update its position like we did before. And we can also look at the impact class. It's very simple. It just exists for 1.5 seconds, and once this timer runs out, we destroy it. So nothing complicated here. So now let's run the code and see what changed. So we can see the enemy. Once we get close, it starts following the player, and once it gets to us, we start receiving damage. When we run away, it goes back to the castle and starts attacking the castle, and you can see that the HP ticks down. And once we kill it, it goes to ragdoll and disappears after 3 seconds. And you can also see that now we have this projectile effect. It looks quite terrible, but I'm not gonna fix it. So, but you can do much better with your own effects.